All right, so let's take a look at all these transformations that we've been doing in the what we call telekinesis and see how it plays out in some of the word problems that you might have seen before. So, for example, a manufacturer in the business of producing small models of the Statue of Liberty, she finds that the daily cost is in dollars is C. So this is the cost, and in dollars of producing n statues. So number of statues. All right, is given by the function. So C of n. So C is a C when n statues are made. So cost when n statues are made is minus n squared minus 120n plus 4200. Okay, so that's certainly something, one form of the function. So we have two questions. One of the questions is how many statues should be produced so that the cost will be minimum? And then the second question is what is that minimum daily cost? So let's see. If we have two functions, two forms of the function, because we're also told that the same function can be written as n minus 60 all squared plus 600. So let's see what kind of information we might be able to find out from these two functions and see if any of that information will help us answer the question. So first of all, do we know the shape of this function? Right? Remember, we're looking at the family of the functions that we're looking for, and then we have an n squared. So the shape is we're going to start with a base shape of our n squared or x squared. Okay. Now, what else do we know? We know that there's some shifts going on. We know that instead of the function actually being crossing at 0, 0, if n is 0, then actually the function is going to cross at 4200, right? Because if n is 0, then C of 0 is 4200, right, from the first function. What else do we know? We also know this, that our peak, our vertex, is going to be shifted to the left or the right, and also going to be shifted up, right? So it would be going shifted up 600, because all the values are shifted up 600. Now, and it's going to be, we're going to be squaring 0 when n equals 60. So that's very interesting. So this is going to, the vertex here is going to move 60 over to the right and 600 up. So let's draw our new function, our actual function for C. So it's going to, vertex is going to be at 60 and 600 up, right? That's going to be our vertex. And it's going to go through the y-axis at 4200. So that's going to be way up here somewhere, 4200. So it's going to look something like this. That's our C of n. This is our n. Right? Do you see that we were able to get these three facts from this, right here, from this, and from this? We were able to get these three facts. In fact, four facts. The fact that it was a parabola, that it was a shape of an x squared, came from the fact that we saw n squared. The fact that it would cross the y-axis at 4200 came from here. The horizontal shift, the fact that we needed to be at 60 for the vertex, and the vertical shift for the vertex, that we needed to be up 600. So let's see what the questions are that are being asked. So, how many statues should be produced per day so that the cost will be minimum? So this is the point with minimum cost. So how many statues Well, that happens at 60 statues. And what is that minimal daily cost? Well, what is that cost? The cost is 600. Right? Does that make sense? That we were able to read that off just from the information that was given. We didn't plot any, what if n equals 0, if n equals 1, if n equals 2. We didn't go through plotting or creating a table of values. We just looked at the characteristics of this function that was given. All right, now, so we did question 1, and then we're also going to do question 3 together, and then questions 2 and 4 I will leave for you to play with, and if you have any questions, let me know. So the daily profit, P in dollars, for a company that makes tennis rackets is given as P of X equals negative X squared plus 240X minus 5,400, or also negative X minus 120 all squared plus 9,000. Where X is the number of rackets produced each day. So we have some explanations here. So P is the dollars of profit in dollars. X is the number rackets produced in a day. And we need to answer a couple of questions. One is, how many rackets should be produced to maximize the daily profit? And the second is, what is the maximum daily profit? So let's see what we know about this function. First of all, you recognize that it is an x squared function. So it's going to be something like so the base is quadratic. Right, x squared. We also see that there's a minus, that it's negative. So there's going to be a flip over the horizontal axis, right? So it's going to go like this instead. And we also know that it's going to be, that we're subtracting 5,400. So if x is 0, right, then the value of profit is negative 5,400. So 0, negative 5,400 is a point. Now, let's take a look at the second form, this other form. So we have an x minus 120 all squared. So the vertex here is going to happen when we're squaring 0. And that happens when x is equal to 120, right? And finally, the vertex is going to be shifted up 9,000. Okay, so let's see if we can draw all of this together. So the vertex, so first of all, it's going to be an upside down parabola. The vertex is going to be at 120 and shifted up 9,000. So 9,000. So this will be the vertex. And what's also going to happen is that it's going to cross the x-axis somewhere at minus 5,400. So it's going to look something like this. We don't know these locations. We could if we were able to figure out the factored form, right? Because we were able to do that with Algeblocks. But at this point, we don't. However, we can say, all right, well, we can see if we can answer the question, how many rackets should be produced to maximize the daily profit? So what we're looking for is this point and how many rackets, right? And then what is that maximum daily profit? Well, at this point, it's this much. So we should be making 120 rackets per day for a maximum profit of $9,000. All right. Now, I will leave questions 2 and 4 for you to play with. And again, you're looking at trying to tease out some information that's easy to see from the forms of the function that are given to you. All right, and if you have any questions with 2 or 4, let me know and I'll be happy to record another video.